All right, so I'm going to release your lab number 2 very soon. I'll definitely try later tonight. If not, definitely early tomorrow morning. So you definitely can start working on lab number 2. And your lab number 1 solution, I'm also going to release a tutorial video for you, so you can also take a look. If you want to develop from scratch together with me, you can definitely follow through the video. It's very thorough. I'll make it available as soon as I can. And for today's lab session, it's completely optional. If you want to drop by WAC105, the TAs will be there. You can definitely ask questions as well. Okay. And for your programming test number 1, it will be next week, right? You pretty much know the guy, practice test 1 as well. And then this Friday, there will be an in-person review session. It's going to be hosted by a TA, but myself, I will be there as well, just in case you got questions. I'll be there. And we might try to record the video, but it's going to be decided by the TA, if they want to release the video. But I would say to be safe, come by, all right, for the review session. It's going to be worth it. I'll be there as well. So I'll be more than happy to stay a little bit longer if you got other questions. So that's okay too. Okay, just come by, 2 p.m. Friday. Any questions about the course? So we got basically today's lecture and also 2 more before the reading week. So we'll see how much we can cover. I'm hoping at least to definitely finish exceptions today. And then also we'll talk about some JUnits testing by combining some exceptions. I'm hoping to touch upon just a little bit about Java equality before the reading week. We'll see. Yes?
With regards to the practice test one that you provided,
yeah.
Will it be a direct reflection? Will the prog test one will be a direct reflection of the practice test, or will it be like a...
You're saying comparing the practice test 1 and also the actual programming test 1?
Yes.
I would say, as I said, these practice tests are really meant to be an example. Okay. I would say practice test 1 is actually rather long, so the actual test may be a little bit shorter, but there might be certain aspects that may not be exactly covered by the practice test 1, but it's listed as a coverage topics. So you definitely want to study that as well. So I would say you definitely can take that as a good reference point, but don't completely rely on that. You should also go over the cover material for the test. Okay, yeah, it's always the case for written test and programming test. Yeah. All right, let's do a recap quickly. And then we'll move on to more exceptions. Today is mainly just about doing more examples and also review some of the principles that we have spoken about. Exception is a little bit tricky when you first learn it, but I think after going through the generalization and the different version of example we have spoken about so far, you just need to dive into details and struggle a little bit and ask good questions. I think that's the best way to learn. All right, so we basically talk about 3 versions of the example there. Is a very simple call chain with only 3 methods there, right? So version number 1, okay, first of all, the method where the exceptions originated, we usually just specify it. We don't really catch that. So that means the exception will be thrown to the next caller in the stack, which will be B. And this method here will be subject to catch or specify requirements, in which case, in version number 1, we choose to catch it. Meaning that beyond this point, after b.mb, we are no longer subject to catch or specify requirements, right? And then for version number 2, the b.mb will choose to specify it. In that case, it will be propagated further. So this is very important because you have to identify somewhere in the call stack where is the very first method that will choose to catch the exception. That's very important because beyond that point, all the subsequent callers will not be subject to the catch or specify requirements anymore, right? That's something we generalize as well. So be ready to answer questions like this, either at the concrete level, if I give you some example, or maybe at a more general level, if we just use symbols, right? We cover both in the lecture. So the 3 versions, and version number 3 is really something you want to avoid in reality. Of course, programmatically, it is possible for all the callers on the call stack. You simply don't try to catch it. You always specify it. So that means the exception, once occur, it's just going to be propagated all the way to the console. That's not the way to go. It's not a good design. You don't really want any user, let's say some console application, to see the exception directly thrown to their face in the console. It's definitely something you want to avoid. Okay? So version number 3, think about it's programmatically possible, but it's something you want to avoid as a design. Okay. And then we talk about this generalization here, right? I'll let you study this generalization again in detail. But it is so important to identify where is the very first method that's going to catch the exception. Everything before that or on top from the stack will be this one will be the first one catching it. And all this previous one will be the ones specifying it, right? Beyond this point, starting from this point onwards, all these methods will not be subject to catch with specified requirements anymore, right? So that's the general principle. Of course, this is kind of symbolic. You just have to know where that MI is, really here, all right? Do you guys have any questions about this diagram here? Is okay? Hopefully that's reasonable, right? Okay, so that's about it for last time. Last time we really dived into details also about how you can trace the program on the paper versus on Eclipse. So both are important, right? I might kind of ask you in different form in the written test or in the exam. So you want to really practice as much as you can before the test. All right, so let's now talk about some example today. So first of all, let's review quickly just about the two different scenarios. We talk about whenever exception is possible, right? When you are calling a method that throws certain exception, the exception may or may not occur. So there are two possibilities. When the exception occurs, that means your flow will be interrupted. If the exception does not occur, your flow will just go as normal, just executing the method call, right? Just remember that principle. So let's now talk about the two different options here and just review the execution flow. And then we'll do one more example about tracing, okay? So the scenario is, let's say the caller really chooses to catch in order to handle the exception. So that means you will see the try and catch block and try and catch block. So these two blocks are just identical. I want to show you the two flows in parallel so you can see exactly what the difference is. Okay? So the method we are calling is this one here, O.M. Okay, let me make it thicker. We got O.M here, and also we got O.M here, right? So this method call may throw some exception, may or may not always, but sometimes. Okay, so what we want to think about when it does throw the exception, what happened? When it does not, what happened, right? So let's talk about two scenarios. So you can think about the green one here is like a normal execution when the exception does not occur. And the red one here is the abnormal flow where the exception did occur. So let's now annotate it quickly. So this scenario here is when the exception did not occur. So the whole thing would just terminate normally without even entering any catch, okay? So this means the exception does not occur. Versus when we are calling just the same method, but in some way, for some reason, maybe the input value is negative, for example, in that way, exception occurred. Exception occurred. All right? So these are the two separate scenarios. Let's just label about the flow of execution just to see very quickly. Okay, so we actually start with the try block, right? Okay, I can even put one over here. That simply means before the try block, there might be some lines of code. They will be executed for sure before we even get to that method call. And then we get to the very first line of the try block, which will be the method call, right? So if you imagine that, if we step into O.M, and then we can try to see if the exception will be thrown from there. Let's say exception was not thrown. In that case, we will be able to proceed to the rest of the try block, right? This is very important insight, okay? And then once we get to the end of the try block, you can think about this is the end of the try block. In that case, we're just going to bypass all the catch. Think about catch block will only be used if you got some exception that's thrown and also matched. If no exception has occurred, no catch block will be executed. Okay, that's a simple principle. And then you can think about also here, okay, I'm going to highlight it. This is the try and catch block right here, okay, this part here. That's the try and catch block. So once the try and catch block is completely executed, in that case, the rest of the method should still be executed, right? So that's why you should also go for number 4 right here as well, okay? The rest outside the try and catch block. So that will be the flow for when the exception did not occur, just normal, okay? You only execute the try block completely without hitting any catch block. And anything outside the catch block should still be executed, right? That's a normal flow. Let's see the abnormal flow just to see what the similarity and differences are. So we still try to execute anything before the try and catch block, and then we execute this method call. So now this is important, right? So now imagine that O.M is going to take some input value here, and then it does trigger some exception. In that way, the rest of the try block will just be bypassed. We don't go there, right? That's something we showed last time. Where should we go? It's going to go to one of the catch block, which actually specify the exception that we are expecting, right? So I'm going to show you one example a little bit later today. So it is possible to have multiple catch block in your code, and you might need that actually for your lab number 2. Okay, I'll show you that. So let's say we only got one possible exception. Let's say that exception really occur. In that case, you're going to match the catch block. You can think about conceptually, this will be number 3. Right? You're going to go to the relevant catch block, and then you're going to execute everything inside the catch block. All right? And then at the end, you're also going to execute everything outside the try and catch block as well. Right? Okay, so that'll be the flow. Okay? So what's really the common part? The common part, let me just highlight in maybe orange. The common part will be anything before and anything after the try and catch block, and also anything that will lead to that particular method call. You can think about this method call will be executed for sure. If there's any code before this method call, they will be executed as well in both cases. But in the case of the normal flow, you will only execute to the rest of the try block. But for the abnormal flow, you will bypass the rest of the catch block and then only execute the catch right here. Right? So that clearly highlights the differences between the two. All right. Question about the flow. We're good? So this part here is just about if the caller chooses to catch. Let's see what happens if the caller chooses to specify. Okay. Okay, just one more thing to actually mention, right? Just some extra note you may take. So this part here simply means bypassed, because the exception did not occur. On the other hand, this part here, which will be the after the method call and for the rest of the try block, this part here is also bypassed because the exception we're expecting did occur. Right, like that. Okay, so let's now talk about another scenario. Let's say the caller actually chooses to specify, which might be a little bit easier to understand because you don't have the try and catch block complication, right? Let's take a look. But this one here will be interesting for the abnormal flow. I want to also visualize what's happening. Okay, let's bear with me. Let's think about these two, okay? So again, we're calling this method here O.m right here, and also O.m, right? And then you may or may not throw that exception, okay? Again, we distinguish between the two scenarios. Let's say scenario number 1, the exception did not occur. Did not occur. And this will be the alternative scenario where the exception did occur. Right? You can obviously see that we got specify option, right? Specifies option throws, right? So there's a different scenario. There's a different option chosen by the caller. All right, let's see the execution flow. Similar as before, anything leading to the method call will be executed for sure in both cases, right? So you can think about this part here. I got 1 here, 2 here, 3 here, all the way to calling the method. Similarly here as well. 1, 2, 3, and 4. So far, both scenarios will be the same. But the difference is going to be, what if the exception was actually occur? Let's think about when the exception did not occur. If it did not occur, it will simply go on to the next. All right? It is very important to know the following. Okay, I'm going to write it down here. If you're able to proceed after the method call, this simply means the exception did not disrupt the flow of execution. So you're simply able to go after this method call to the next line. On the other hand, if the exception did occur, what's going to happen is you're just going to bypass the rest. And then this method here is actually going to terminate abnormally. Okay, I'm going to go give you a little bit more detail, but let me just say that first. So you can think about here. So these two will be bypassed. So here simply means the exception that's thrown disrupted the flow of execution. All right, so that means this method here is going to terminate right here. Okay, let me just write one more thing. You can think about C1 and 1. This is the method. C1 and 1 terminates abnormally here. Okay, it is important to know that it terminates and also abnormally. Okay, that's so important. All right, and let's try to visualize this scenario here just to connect to the call stack, right? First of all, let's see the caller and callee. Once you know who the caller is, who the callee is, you know where to position them in the call stack, right? So you know that C1 and 1 is a caller, right? Agree? You're calling this method here. So C1 and 1 is the caller. Versus over here, I got C2 n is a callee. Right? Let's now visualize this in a stack like this. If you put a stack like that, all right? So we actually got some entry point of execution. At some point, we call C1.m1. At some point, C1.m1. And C1.m1 in turn calls C2.m. Do you agree? This visualization here, right? It's very important for you to analyze what's happening. I'll pause a little bit for you to see. Everything I'm drawing here on the stack is based on the code I'm seeing. I'm not doing anything more, right? In the context of C1.m1, I'm calling C2.m. So that's why I can position them in the call stack accordingly. And then what's happening here is this method here, C2.m, is where the exceptions originated, possibly. So I'm just going to specify. So this exception is thrown. And in C2.m1, the caller, it also chooses to specify. That means the exception will be also propagated to its caller. But we don't know, we don't really know who that caller is. We cannot see that in the code. Okay, just know that this one here will also be thrown. Okay, I can write a little bit better. All right, so this is also important because this part here is going to be thrown, right, to its caller. Okay, just to the caller of C1.m1. All right. All right, any question here? Right, so basically I talk about 4 scenarios in total, right? You want to make sure each one of them is actually can happen at the runtime. When the caller chooses to catch, you have 2 scenarios. And when the caller chooses to specify, you also got 2 scenarios, right? You want to know all 4 of them. Okay. Any question about any one of these? All right. Let's now move on. Let's now talk about some interesting tracing here, right? So we are now actually just trying to somehow exploit the way execution flow is going to be either proceed or interrupted. So these are the 2 scenarios. We're going to use this kind of fact to write some useful application. So the example I'm going to show to you now is about writing some useful application. When we get to the new lecture today about the second half, we're going to see that how you can set up your JUnit test in a way that's going to test the exceptions properly. Okay, that's something we'll see as well. But both applications are just going to exploit the execution flow alternative, right? Either exception occurring or not occurring. Let's take a look at this one. That's kind of the version 2. And for version 1 here, it's basically much simpler. I'll leave that as like an exercise for you. But let's do the harder one in class. Okay. So we have an exception called invalid radius exception. Okay, let's say. So this exception here is can be thrown from the set radius method right here. All right, so the set radius method specifies it. So when the radius passed is actually negative, we throw the exception. Otherwise, we'll set the radius to be r. Okay, simple. And then we're going to trace this one here. Let me just give you a little bit of background here. If you look at the main method here, so in calculator, circle calculator 2, we have a main method, console application. And we have some Boolean variable here, right? Initialized to be false. And this Boolean variable somehow is used in the Boolean condition of the while loop. That means as long as the negation of this Boolean variable is true, we're going to stay in the loop. As soon as this value here turned out to be true, not true is going to give us false. We're going to exit from the loop, right? That's what you can see right away. We're going to see exactly how that can be done. And we only set this Boolean variable to be true if we are able to go from here to here. And remember, set radius may throw some exception. If we are able to go from here to here, what does that really mean from what we just covered? That means the exception did not occur. If the exception did not occur, that means we can set this to be true. Accordingly, this Boolean expression here will be false. We're going to exit from the loop and stop prompting the user for any further input. That's the overall picture. Okay? But we're going to see exactly how this is going to work out. Okay? We're going to see. Okay? Excuse me? Hello? Can you take off your headset, please? You. Headset. Yeah. I'll appreciate you don't wear your headset in my class. No. Can you take it off, please? Thank you. All right, so let's now trace this program over here. Okay, so we actually got two variables to trace. So let's say the user will first enter -5, all right? And then it's going to enter, well, -5 apparently is not a valid radius. Somehow it's going to trigger the exception. But we are not going to throw the exception directly to the console. We're going to somehow prompt the user to say, enter another one, until they enter something that's not negative. So 10 will be something we can calculate for the area. Okay, let's see exactly. So let's now set up the variable here. So we have, let's say, this Boolean variable here. So we have right here. So that's the input radius is valid. Initially, the value is simply just false. Okay? And then we're also going to have a variable here to read the radius value from the user. Okay, we're going to see exactly. So let's make the following assumption. When the user is first prompted, they're going to enter -5, and then they're going to enter and then enter 10. Okay. So let's now also put some console here so I can show you exactly what's going to be printed out. So the console is going to be right here. Okay, console over here. And then we have the cost stack. So everything will be ready for our tracing, right? That's a cost stack. All right. So the entry point of execution is right here. So circle calculator 2, and then we call the main method, right? So circle calculator 2 dot main. Okay. Let me just do a little bit of preview just for the cost stack so we don't need to worry about it later. At some point, we're going to call set radius. Okay. So set radius comes from the circle class. Okay. So that one is going to call circle dot set radius, right? So that's going to be the cost stack. Okay. Okay, let's now trace line by line. And I'm also going to use the labels to tell you exactly how things will actually go. Okay. So we're going to have line number 1, set up some scanner. Okay. Number 2, we're actually going to initialize the value to be false, which is already here. And number 3 here. We're going to check to see whether we want to enter the while loop for the very first time. Okay? At the moment, you can see input, this Boolean variable here is false. Not false is going to be true. So we go in for the very first iteration. Okay? And then we're going to go for number 4. We're going to print out some line right here. So I'm going to say enter a radius. Enter a radius. And then the user is going to enter something. Okay, line number 5 here is going to, R is going to store the value that's from the user. And we're assuming that the user is going to enter -5. All right, so they're going to enter -5. After that, R is going to store -5. Okay. And number 6 here, we're going to create that circle object. Let's not worry about visualizing the object. It's not the point, right? Just initialize the object here. And then we're going to enter the try block, right? The first line there will be number 7, right? We're going to just call the setRadius method. And then in this case, R will be -5, right? And we don't really know whether we should really go to the next line or not, because if the exception occur, we don't really go to the next line. If it does not occur, then we go to, right? So let's see. So let's step into setRadius. So setRadius is over here. So R will be -5 right here. And then it's going to be number 8. We're going to check to see this if condition. So -5 less than 0, true. So number 9 should be right here. So we're going to throw that exception. So you can think about in this way, this method here is going to be removed from the stack. It's going to terminate abnormally, right? So after this is removed, we're going to go back to where we are in the main method, which is this line. So now we have some exception thrown. So think about when it is -5, we know that the invalid radius exception is thrown from here. When it is thrown, we don't really go to the rest of the try block. We simply find the catch block that's going to catch that exception. In this case, it's going to be right here, right? It's going to be caught right here. Okay, right here. And then we're going to print out try again. Number 10. Okay, and then we're going to say try again. Following so far? All right. So we somehow use the fact that we are able to prompt the user to try again. But we place this print statement here under the catch block, knowing that if we get to this catch block, we know that exception has occurred. So we should ask the user to try again. Okay? So this try and catch is done. So now we are reaching the end of the while loop right here. So we're going to go back to the beginning of the while loop and then check again, right? You can see the value for input, this Boolean variable here is remain to be false. So not false is going to be true. So we're going to try again, right? Second iteration. So let's now, I'm going to change the color right now. So let's say we're going to try again. So this will be 11. So 11 will be we evaluating the while loop. So we're going to go again. And then 12, we're going to print out, ask the user to enter the radius. Enter a radius. And then number 13, we're going to prompt the user to enter the next double again. And in this case, we assume they're going to enter 10. All right, so 10 in this case. So that means R is now going to be storing 10. That's a new value, okay? And then 14, we're going to create another circle objects, right? And then we're going to enter the try block. So that will be 15 right here. So 15 will be set a radius to be 10. So now, whether or not we should really go from 15 to this line here depends whether the exception will occur. All right, let's step into it. So if you step into the set radius here, so set radius. So now you'll be 10 right here. So we got 16. 16 will be checking to see if 10 less than 0. False. So go to the else part, and then 17 right here. So that one there is going to set a radius to be R. You can think about the radius over here. It might be a box over here. It's going to be set to be simply 10, which wasn't the case in the previous run because that was negative. All right, 17, and then we reach the end of the set radius. So now the method also terminates, but normally without any exception. So what we do is we're going to resume back to where we were. set radius call, right? So now this time, no exception has been thrown. So let's make a mark over here. So now from this one here, the invalid radius exception not thrown. So that means we can go directly to 18 right here. You can see this is a very critical line. Because the exception did not occur, we are now going to reset the Boolean variable here from false to true. All right? So after that, we're going to print out two things over here. So 19 and 20, right? We're simply going to say something like circle with area, whatever, right? You can do the calculation, right? It's going to be some number. That's going to be the area according to the radius being 10. Right, 20 here, and then we simply bypass the print line. We don't go to any catch block, right? And then we reach the end. So once we reach the end of the while loop, we're going to go check again this while condition. So input radius is valid. Right now it's true. And remember, there's a negation here. Not true is going to be false. So we exit from the loop, and we're done. All right? So this part over here is going to be not true, which will be false. That means exit from the loop. So overall, from the user's point of view, it's actually very useful because as long as they're entering some negative value that's not valid for radius, you just keep prompting them until they enter the very first one number. Of course, I didn't put it. It should be just 10 in this case. Right? Until the very first number that's valid for radius, and then you will calculate it and terminate the program. Okay? What you should really try is this. So exercise you can try. What if the user actually tried two exercises? Number one, what if the user simply enter, let's say 23 at one go? Okay, what's going to happen? Number two, what if the user enter, let's say -5, followed by -10, followed by 46? What's going to happen? Okay, you want to really see very thoroughly about how this Boolean variable is going to control the entrance and exit for the while loop. Okay, but if you already understood how this is going to work, you should be able to do that as well. Right? But the most important thing is to label about the flow sequentially. Okay? Any questions? Any part that's kind of confusing, not clear? Okay, go ahead, please.
If it's like through like two different exceptions, let's say initially when you went to set radius, right? You threw like an invalid radius exception, but in your main public class, you said like negative value exception.
You're saying that, okay, I can definitely, it's a good insight. Okay, let me just hand wave a little bit, but okay, in an intuitive way. So guys, you can also listen to this, right? So this one here, let's say second exercise. Since the very first two inputs are invalid, so you can think about overall how many exception objects will be created and thrown. 2. This one will trigger 1. This one will trigger another one. Okay, let's see how exactly what's going to happen. When the user enter -5, so we're going to execute this line. And that exception is going to be somehow caught by this catch block. And then we're going to print it out. As far as that first exception is concerned, it's already gone. It's no longer there. So when we go back to the while loop, and then the user enter a second negative number, in that way, we're going to go here, and then we're going to execute the throw for the second time. It's going to throw the second object. But the second object will also be caught by this one here as well. Every time once the exception matches the catch block, it's basically gone. You no longer have to handle that anymore.
But if we don't give a catch to like any class and
Yeah.
for all of the classes, we have like throw exception.
Yeah, exactly. So
the final code have like the main exception or the exception from the
So let's say hypothetically, if we didn't have the try and catch block right here, let's say we didn't have it, but we need to handle that. So the only option left would be to specify it. Let's say we don't have the try and catch block. Instead, we actually got the throws invalid radius exception. That's exactly what we kind of set in version 3. So in that way, the exception will be thrown for the very first time directly to the console, to the user. So you don't even get a chance to really get the user to try again. Not really. Okay, so that's why this program here very nicely let the user keep trying. Okay, so we'll see this pattern here again, just to see some even more useful application for you. Okay, we'll get there. Okay. Yeah, so guys, really study this pattern here, right? It's very useful, actually, to see, also train your logic mind to see how things can be traced. Okay. So for version number 1, I'm going to leave that empty just for you to try. Okay, you can, you don't necessarily have to really write something down. Maybe you can even trace in your mind. I'll leave the option to you. But try some valid input and also try some invalid input just to see. But apparently the version 1, the simpler version, has no loop, right? But you just got to know exactly the execution flow. Okay. All right. So one more thing, one more example, right here. So this one here is basically just about 3 classes. Well, we actually deal with, like a method called chain that's actually of size 3. So let me just mention to you, and then there's only one single line I want to explain. Otherwise, the rest can be up to you. So let's say we got 3 classes. Let's start with the entry point of execution. We got bank, application, and then we got a main method. So that's the entry point. Okay, let's build out the stack together. So we got bank application dot main. So we start with that. And then we are trying to call a method right here. So we're trying to call the withdraw method on B. B was declared to be of type bank. So bank.withdraw is the next, like the callee, right? So for that one there, we got bank dot withdraw. All right. So if we go to that particular method, bank.withdraw, bank, and then withdraw, right here. All right. So this is where the complication might come from. Okay. So let's take a look. So from there, we actually got this method here, accounts I dot withdraw. All right. But somehow we want to see what's really the callee right here. Apparently, the method being called is actually withdraw, but we're calling that on subarray indexing. Right? So that's something I want to make sure you're comfortable. Okay? So if you look at just that line, so that line there, we got accounts at index I, and then we say withdraw. You can see that the withdraw method here has the same name as the withdraw here. But are you really calling the same method? That's something you want to decide, right? What's the type of the accounts I here? Which class should I go to? The hints can be found in this class. Let me rephrase my question here. I got accounts I right here. That's the context objects for calling this withdraw. If I want to specify exactly what this callee is, it's a withdraw method. But from which class? Account. Okay, good. That's the right answer. So which line should you really look at? You should look at the declaration right here, right? You should look at right here. Accounts over here is an array. But since you say index I, that tells you that you should really go to a single account as opposed to an array of account. All right? So what we have is this. Accounts over here is of type accounts array. And then once we get the indexing over here with the index I, it's going to give us just the account class. So that means the callee will be account.withdraw. Okay, so that's the next level in the stack. So that will be account.withdraw. So this is why we kind of said in the beginning, it's not sufficient just to put the name of the method. You ought to say what's the class the method is from, because methods from different classes might have the same name, in which case you really want to disambiguate by having a class name. Okay, you got account, you got a bank. All right. So we can also go there. Okay, so that's the account that withdraw. So we got account and then withdraw. So this is where the exception might be thrown. That's where it is originated. All right, like that. Okay. Okay, so for this one here, I'll let you do the trace. I already told you the tricky thing. which is about to determine which method you should really go to by looking at just this array indexing. That's the most tricky part. I want to make sure you're okay. Other than that, you should really try different inputs. And I suggest give a try on some negative value. Are you able to withdraw this amount? That's a question. Okay, so do the tracing and then find out. Also, you should also be able to draw diagrams like this, right? That's something we also have been doing about doing array from lab 0 part 2. Okay, make sure you draw the diagram and also try to look at exactly how this scenario should be traced. So that's the exercise. All right, any questions about this example here? We're good? Okay, just make sure you know how to figure out the type for array indexing. That's the main thing. Okay. All right, so we got 2 more examples about exception. Okay. So let me just go for one more, and then we'll take a short break, and then we'll do the second one after the break. All right, this one here kind of shows to you, you may have multiple catch block right here. Okay, you can see we have a single try, and then we got multiple catch. For now, we are making the following assumption. Any exceptions you're trying to throw from individual line, they have nothing to do with each other. So you can put any order you like for the catch block. I'll write it down. Assumption. All the customized exceptions you create, you know how to create exception classes. Customized exceptions are unrelated to each other. And the consequence is, for example, here you can see that I say I want to catch this one first, or I catch this one later. It doesn't matter the order. You can even swap the order. You can say catch this one later and catch this one first. You can simply say this will be the first catch and this will be the second catch. That'll be fine as well. Okay? That's an important assumption we're making. Because in Java, it is also possible for you to build some inheritance hierarchy among the exceptions, in which case the order of the exception you want to catch really matters. But we don't want to go for that complication for now. Right? So that's why we have some assumption to make right here. Okay? The order of the catch blocks does not matter. All right? Okay, important assumption. Okay, let's now try to understand the structure first of all, and then we do some quick tracing. Okay? Basically, the try block over here, we are making 2 method calls. We are making this method call here, and also this method call here, right? For the first one, this one here, it may throw invalid transaction exception, may, okay? This one here may throw invalid transaction exception. If there's any exception from here, it's going to be this one here. On the other hand, the second method call right here, set radius, which is the one we just talked about, that may throw this particular one, if any. So this one here, it may throw the negative radius exception. Okay? So as far as the try block is concerned, when you try to trace it, you have to be careful. This line here may or may not throw this exception. If it does, you have to go to the relevant catch block. And also for this one here, it may or may not throw this particular exception. If it does throw it, you have to go to this catch block, right? Something like that. Why don't we look at one test case together, and then the other one, I'll leave that to you to give a try. Okay? Let's say we do this one particularly. Okay? That would be good enough for us. Okay? Let's say this one here. Okay? Let's say we do this one together. Let's say we set the amount to withdraw to be something invalid. Let's say minus 5 million. Okay? And the radius is something that's valid. Let's say it's 23. Okay, let's see. So if we try to execute this, so number one, create a bank, and then add the account, and also try to do deposit. And then when we reach this line here, we're going to pass the amount, minus 5 million. That one there, if you look back, is actually going to throw, right here, invalid transaction exception, right? That's something you should really try to do as exercise as well, okay? So let's go back. Sorry. Okay, there we go. So this one here is going to throw that exception. So this one here is going to throw that invalid transaction exception. That means the rest of the catch try block will be bypassed. And now we got two possible catch blocks here. So which one should we go to, right? It depends on which one will match the exception that's thrown. This one here, right? You can think about this one is not being matched, so we are not going to execute it. But this one here matches the invalid transaction exception. So that means it's going to be number 5 and also number 6. So that'll be the flow. Let me say that again. The try block here has two potential places for exception, either here or here. Whichever that happened first is going to interrupt the flow of the execution. And in this particular inputs, this one here is going to trigger that exception. So that means the rest will not even get a chance to be executed. So we simply got interrupted. So we go to the relevant catch block. And this exception here does not match the one that's being thrown, right? This one does not match this one. So that one is not going to be executed. So only this one here. Okay. Any question about this? All right. So when you tried out test case number 2, apparently somehow I kind of set a value so that only one exception can actually happen. So you want to see exactly where this is going to trigger that exception and see how the rest of the code is going to be executed as well. Okay. All right. If no further question, I'll suggest we take a short break, and then you can get your iClicker ready. Okay. So I got one more example to show to you. This one will be also interesting. And this one here, we can see the Boolean variable again in a very useful context. Okay, so this one here. Okay, so the context is we have a method there. We don't need to implement ourselves. It's actually from the Java collection, from the Java library. So it's from the integer class in Java. And then there's a static method there, which means you don't need to create a context object for calling this method. You can just say integer dot parse int. But what does it really do? The parse int over here is going to take some string over here. And then taking a string, it can return back to you some integer value. You can see the return type is int. However, you can see as part of its a header, it says throws number format exception. So apparently, when error occurs, this method here chooses to specify, not to catch. Otherwise, if they catch the exception, you wouldn't even see it. Right? So let's see how to use this method here, and then we'll look at some quick case study about how to implement a program accordingly. Let's say, for example, if you call the methods to say integer.parseInt, and then if I simply always pass a string, if whatever that's inside the string can be converted into an integer, then it will return integer. So given a string literal 23, and then we're going to return the int value 23. That's kind of intended usage. On the other hand, if I give it, let's say a string, it's simply not intended to be a number. I just say 23, for example, like a string literal. Or you can say quote Alan, quote Mark, quote Tom, exactly, etc. And then that one there is going to give you the number format exception. Right? So you got two scenarios. Either you get an integer value back, or you got the number format exception back, either way. It's a little bit like for the radius, set radius method, it may or may not throw that invalid radius exception. And by using that exception or the execution flow, you can actually write some useful application, right? So similar idea here, but I just want to show you one more time. All right, so now the task would be, of course, we wouldn't have time to let you think, but you can definitely think about it. You can also try this yourself. We want to write a fragment of code, and then we somehow want the user to keep entering something from the keyboard. And then we want to somehow convert whatever string they have into integer. If they enter anything like this, like a 23 right here, which cannot be converted into integer, we just keep prompting them for another input until they give us something like like a 23 over here. Then we can convert that into 23 and do something else, right? That's basically some program we want to write, okay? Apparently, we need a loop, right? Because we might potentially want to prompt the user for an indefinite number of times, depending on how many tries and errors they want to get into, okay? Let's take a look at the program, okay? So you can also feel free to also write it yourself as well. So the setup is very similar, okay? Let me first of all highlight the Boolean variable here. So we got this valid integer, initially false, and then while not the case, valid integer. And then we set the value to be true only after the method call of parseInt did not throw that particular exception. If it did not throw that exception, if we are able to proceed to the next line, we'll set it to be true, meaning that this Boolean condition here is going to become false. So we can exit from the loop, right? Similar, same logic as before. So what we do now is let's trace this code very quickly to see what's going to happen. So let's say the user is going to enter something that cannot be converted into an integer, and then followed by something that can be converted into integer. Okay, let's try these two. Okay. So let's now start with the label. So number 1 and number 2. And this one here is going to set the Boolean variable to be false. Okay, I'll put it here, right here. So valid integer. That one there is simply just false to begin with. And number 3, we're going to check the while loop. Not false will be true, so go in there for the first iteration. And then we go for number 4, which is going to print out a line. Enter an integer. Enter an integer. And the user, we assume, is going to, first of all, enter 23 as a string. Okay? They're simply going to type in from keyboard 23. That means the user input right now is going to be 23. Okay, so we're going to go, this will be number 5. And go into the try block, number 6. So this user input here, again, is going to be 23. We don't really step into the library method call, actually, because we don't really have access to it. So we don't need to. We just need to know whether or not exception will occur from this line. In this case, it will, right? Because 23 is a string, cannot be converted into 23, right? So we know that this one here is going to trigger the exception, okay? So this particular input here, just this one. The first call over here is going to trigger the number format exception will be thrown. As soon as it is thrown, we are actually going to bypass the rest of the try block. And then we're going to go into the catch block because that one there is the exception thrown is exactly caught right here. So this will be number 7. Okay? And then that one there is just going to ask them to really enter again. So like this line here. Okay? So I'll just say try again here. And then we are reaching the end of the while loop. So we go back to check this condition one more time. And you can see here, not false. It's still going to lead us to another iteration. Okay? So we're going to go for number 8 right here. Okay? And it's going to say enter integer. Oh, let me change the color here. How about that? This will be number 8. All right? I think conceptually you may want to think about number 8 is checking this Boolean condition one more time, right? And then number 9. So we're going to say enter an integer. And this time we assume the user is going to enter 23, okay? So input next line is actually going to be a string 23, okay? So 10 here, and then go to the try block. And then the user input this time is going to be 23 as a string. And now we know that it's going to be converted somehow, right? So this line here is going to proceed normally. Okay, the same line. Okay, so you can think about this line here. The number format exception is not thrown. So what's going to happen is this value here will be stored 23, okay, the variable. And then we're going to go to the next line, 12. And we are reaching the end of the try block, and then we're going to bypass all the catch block and go all the way. All right? So once the user enters 23, we will be able to exit from the loop. But of course, you can extend the code to say you want to take that integer and do something about it. That's okay too. Okay. So in this way, you don't really have to write like any method to process the string yourself. So you do have some utility method from Java that you can use. You just got to watch out for what's the header, any exception that might be thrown. That's the main thing. All right, any questions? So this will be the last example I want to show to you for exceptions. So I think the most important thing is to really see the different execution flow that may be resulted in from a method call, when a method may or may not throw that exception. We're going to see this again. Of course, this will be the last class for this week. For next Monday. For next Monday, I'm going to talk about the JUnit lecture and dive into the technical detail about designing a test, in which case we also have to worry about execution flow. Okay, we're going to see this idea again. So try to review all the stuff we talk about exceptions, before over the weekend. That'll be very beneficial. Okay, we got about 17 minutes. I think we should really cover some basic stuff for the JUnit testing. Okay. Okay, if you're okay with it, let's now move on. Okay. So this lecture here is not really intended to be very long. I'm hoping just today and also possibly just next Monday, possibly a little bit of Wednesday as well, we should really finish this lecture. It's really just about how we can use it, kind of design the JUnit test in a way that's going to see whether exception should be thrown or not. That's something we'll see. Okay, let's see. So we'll talk about, we're going to use some running example like a bounded counter. I'll explain what that really means in a moment. And we're going to see how we can derive the test cases. So deriving test cases is not really within the scope for this course, but I want to show you some strategy, some simple one. So you can feel free to adapt it, maybe for your lab as well, if you want to write some extra test cases for yourself. And then we're going to look at normal versus disrupted or abnormal execution flow. It's going to impact a lot about how the test cases can be judged. Okay. And also, just about intention for the test, I'll talk about it once we get there. And test-driven developments, and also regression testing. We'll also talk about it conceptually. This is really something I want you to also start applying maybe in your lab number 2, right? Since your lab number 2 will be released pretty soon. So that will be a very nice way to exercise that. All right. Let's say we have 2 exceptions for this example here, okay? Let's go over some slides and then I'll remind you some details as well. Let's say we got 2 exceptions. One is called the counter value too large exception. Okay, value too large. Another exception we assume is something called value too small exception. Okay, we got these 2 exceptions, either value too large or value too small. Of course, they might occur in different scenarios, and we want to see when, right? So we're going to design the code for that. So let me just remind you some very quick detail about the catch with specify, right? Very quickly. All right, so let's say in the case of specify, right? It could be that you specify the exception over here where the exception is originated. That's always the case for good design, okay? So this is where the exception is originated. You always use the specify option. So this is where the exception is originated. Another way is you can also try to specify if the callee you are calling also throw that exception. Okay, you can see throws exception. So here we see that the callee M1, by the way, the M1 here refers to the M1 right here. Okay, so this one here is where the callee may throw the value too small exception, right? So these are basically the 2 scenarios for the specify, right? Just a quick review. What about catch? Catch is this C.M2. The M2 is basically the M2 right here, which specifies the exception, right? We are basically saying when you are calling this one here, the callee may throw the value to small exception, right? So we simply are surrounded by try and catch. Try and catch. As soon as we have done the try and catch, you can see that we don't need to specify that anymore. Okay, just make a note quickly. So here, no need to specify. To specify the value to small exception. Right? Nothing new. Just to remind you about catch, we'll specify. Let's take a look at these two classes quickly. Right? So we got a value to large and value to small. So let's say we have a counter class. And then we got two constant. Right? Final keywords, you may have seen that before. Final simply means you don't really change its value once the value is initialized. Let's say we got something called the maximum value for the counter. And also we got something called the minimum value. We got maximum value assumed to be 3, and the minimum value assumed to be 0. Okay? So the counter is going to be initialized to be 0, which is valid, just the minimum. And then you may increment the value for as many times as you like, and as long as it's within 3. You can also decrement the value for as many times as you like, as long as it's within 0. Okay? So these together tells you that the valid values for the counter will be 0, 1, 2, and 3. So these are the only 4 values. Of course, it's just like a contrived example, just to illustrate the point. Realistically, counter value range might be much larger, which is okay. Right? So we got a value for the counter, and then we got some constructor, which will initialize the value to be the minimum, and also you can get a value. Okay? And then we got two methods here. This is important, right? So we got increment and decrements. Increment, of course, is going to add a value to the counter. And also we got decrements here. Of course, it's going to decrement the value, right? The implementation, you can see that obviously, one is to increment the value, and the other one is to decrement the value, right here. And whenever you do increment, for example, from 0 to 1, 1 to 2, and then 2 to 3, when you already reach the maximum, you should not be allowed to increment anymore, because in that way, you get to 4, which is more than the maximum. So that's why when the current value is the maximum, we should really throw that value to large exception. Right? So that's the case to throw. So the increment here may trigger value to large exception in some scenario. Okay? So that would be the value to large exception. Okay? Symmetrically, if you try to decrement, for example, decrement from 3 to 2, 2 to 1, and 1 to 0. And if you want to do one more, it's going to decrement to -1, which is less than the minimum. That should not be allowed either. Right? So that's why we got another exception that might be thrown here, which would be the value to small exception. Okay? So just to recap, these two methods here, increment and decrement, are the only two ways to change the counter value. Okay? And then the increment might throw value to large, and the decrement might throw value to small. Okay? That's easy to see. Okay? So let's now try to do a little bit of conceptual sketch over here. So the next question would be, given this setup, let's say we are required to somehow test this counter class exhaustively. How many test cases do we need, really? You're given basically 2 dimensions to think about. Dimension number 1, the values for the counter may be either 0 or 1 or 2 or 3, basically in between the minimum and the maximum inclusively. That's dimension 1. Dimension number 2, you got either increments or decrements to call. These are the only 2 public methods. Given these 2 dimensions, how many test cases exactly do we need? 2? I can tell you that more than that, but let's see exactly. Okay? Good try, but more than 2. When I say exhaustively, I really meant exhaustively, right? Let's see. Go ahead.
Just one question. I also think too, because like if the value is equal to 0, is it going to throw an exception over there?
That's exactly right. So here, so once I'm going to address this problem precisely. So it turns out you definitely need more than 2. But let's see exactly how many you need. Okay, let's take a look. Okay. So this is our boundary assumption. So the value of the counter should be in between minimum and also maximum, right? Just remind ourselves quickly. So the minimum is 0. And the maximum is 3. So that means the possible value for the counter will be from 0 to 3. 0, 1, 2, 3. So what I'm drawing here is something called like a state diagram. So you guys are most from CS. So for example, when you took EECS 2001, or maybe you're taking it, you have seen something like a DFA, deterministic finite automata, right? So that's really a very standard way to really lay out the states of your variable. But don't worry, let's get some intuition. And this arrow here simply means when the counter object is initialized. The counter is initialized. All right? And then we got 0, 1, 2, 3. Here is the thing. Because the method here is public, increment and decrement. So that means at every possible value for the counter, it is possible to either call the increments or call the decrement. 2 possibilities. Okay? When value is equal to 0, you can either call increments, which will increment from 0 to 1, or you might call decrement as well. What's going to happen in decrement? Should we be allowed to really do so? Or should we signal some error? What kind of error? Value too small exception, right? Okay? Just keep that in mind. Okay, let's now do that quickly. So from 0, I can increments. From 1, I can also increment, in which case I will expect the value to become 2. And from 2 here, I can also do increments as well. All right? And let me just do the normal cases. And then from 3 over here, I can do decrement from 3 to 2. Okay, so this will be decrements. I can also do from 2 decremented to 1. Also from 1 decremented to 0. So you can see so far I got 1, 2, 3, 4, 5, 6. 6 test cases already, right? I got to make sure every value there, if I can do the increment or decrement, the resulting value should be, for example, if the beginning is 0, after increment, the ending value should be 1. That's 1 test case, right? So at least 6 already, but there are more, all right? What am I missing here? Exception might be thrown, right? Yeah, maybe that's something you're about to say. So let's see here. So let's say we are at this point. If I try to do increments, I should not be allowed to do that. So here, value too large exception should be expected. All right. On the other hand, if I try to do from here and go for decrements, I should also be not allowed to do so. And the value too small exception should be expected. Are we okay so far? Okay. So there are 8 test cases with 1, 2, 3, 4. Yeah, there are 8 test cases needed. Okay, that's the final answer. But I want to say more to it, which is important. For each test, we want to think about what's the expectation. Let me just hand wave a little bit. I claim that for all these test cases right here, either to increment from here or to decrements from here. In all these 1, 2, 3, 4, 5, 6 test cases, do we expect any exception to be occur? We don't. What if some exception occur? That means there's something wrong with the implementation, in which case we should fail the test. Okay? How about these two? For these two here, if I try to call, for example, decrements when the value is equal to 0, do I expect some exception to occur? What if it doesn't occur? The test should fail. So exception happening doesn't really mean you have to fail the test. Depends on what your expectation is. Okay, let's now write this down and then we're good for today. Okay, but it's important to write this down. First of all, I'm just going to say all these right here. All these cases right here, okay, I'll say star. All these cases, value too small exception, or value, okay, none of them is expected. And value too large exception, not expected. What does that mean? That means if any exception occur, we should fail the test, right? If any exception occur, fail the test. Okay? So you can see in this case, if any exception occur, we fail the test. Okay? Notice that. Okay? Exception occur, we fail the test. Only for this blue one. Let's now look at another category. This one here. Okay, this one here. And also this one here. Okay, the pink one, these two. Okay, what's really so special about them? Okay, for these two, I'm just going to say star, star. Okay, star, star, and star, star. Here, either one of them is actually expected, right? For example, if I'm running this one here, I do expect value too small exception to be thrown when I try to decrement. And similarly, this one here for value too large. So value too small exception or value too large exception expected. What does that mean? Okay, if the expected exception did not occur, if the expected exception, if they occur, that way you should really pass the test. So what I want to highlight here is this. You can see exception occur, somehow we need to pass the test. So what this really tells us, which I'm going to elaborate next week. Okay, give me 1 minute, please. Okay. When the exception actually occur, you may either have to fail the test or pass the test, depending on which test case you're really talking about and what the expectation is. Okay? So the tricky thing for next week will be we have to set up the test cases for these two categories. So for each one of them, you ought to know what's really the expectation for the test, whether you're expecting the exception to occur or not to occur. And the test and fail should be defined accordingly. That's something we'll see. All right, thank you so much. And I'll release your lab number 2 very soon. And you can work on that as well. Thank you.